everybody. Our today's topic is pressure. 5.1 density and pressure. Definition: the density rho of an object of total mass m and volume v is given by density is equal to mass over volume. The units are usually taken to be kilogram per meter cube. The specific gravity of a substance is the ratio of the density of the substance to the density of water. Density of water is equal to 1 times 10 to the power of 3 kilogram per meter cube. Pressure: when an object is immersed in a fluid or gas, it experiences a uniform inward force over its entire surface due essentially to the weight of the fluid sitting on the top of it. The pressure on the object is defined to be the force per unit area. The unit of pressure are normally given pascals. 1 pascal is equal to 1 Newton per meter square. Note, at the Earth's surface, the pressure felt by an object due to the weight of an atmosphere above it is 1 atmosphere, which is equal to 1.01 times 10 to the power of 5 Pascal. Variation of pressure with depth. One might guess that the deeper you go into the liquid or the gas, the greater the pressure on you from the surrounding fluid will be. The reason for the increased pressure is that the deeper into a fluid you go, the more fluid and thus the more weight you have over top of you. We can calculate the variation of pressure with depth by considering a volume of liquid of height h and cross-sectional area A. In this volume of fluid is to be in equilibrium. The net force acting on the volume must be 0. There are 3 external forces acting on this volume of the fluid. These forces are: 1. The force PTA due to the pressure on the top of the volume of the fluid. If the fluid is open to the air, PT is equal to P naught, which is equal to 1.01 times 10 to the power of 5 Pascal, which is atmospheric pressure. 2. The weight of the volume of the fluid. Weight is equal to mg. Remembering the definition of density, density is equal to mass over volume, and that the volume of the fluid may be calculated as volume is equal to area times height. We can write the weight of the fluid W is equal to rho GHA. Number 3, the force pushing up the bottom of the volume of the fluid, PBA, due to the fluid between the volume under the consideration. If we take the up direction to be positive and add the forces, we get PBA minus rho GHA minus PTA is equal to 0, which gives PB is equal to PT plus rho GH. This provides the general formula relating the pressure at 2 different points in fluid separated by depth h. Note, only the density of the fluid and the difference in depth affects the pressure. The shape and the size of the container are irrelevant. Thus, the water pressure 6 inches below the surface of the ocean is the same as it is 6 inches below the surface of a glass of the salt water. Idea: Pascal's principle states that any pressure applied to an enclosed fluid is transmitted undiminished to every point of the fluid. Thus, a pressure of P1 is equal to F1 over A1 applied downward to the surface on the left of the container gets transmitted as an equal pressure upward of P2, which is equal to P1 on the surface of the other side of the container. The force on the other side is therefore F2 is equal to P2 times A2, which is equal to F1 times A2 over A1. Thus, if A1 less than A2, the transmitted force F2 is greater than the applied force F1. This is the principle behind the hydraulic press. For example, the transmitted force F2 is used to balance the weight of a car in hydraulic lift problem at the end of this chapter. Next time we'll see about pressure measurements. Until that time, study hard, and if you have question and comment, write on the comment bar. Don't forget to subscribe Mame Physics Tutorial YouTube channel, and also follow me on the TikTok channels. Have a nice time.